Very good afternoon. Today, let us see that Turing machines, our eighth topic of our theory of computation. So, what is a Turing machine? How the Turing machine is working? Let us see that. The Turing machine introduction is a very powerful machine that could be simulate modern day computer. Why design such a machine is if a problem cannot be solved using Turing machine, then it implies that problem is undecidable. This is called computably versus decidability. Turing machine definition. There are 7 tuples machine is called Q set of state, machine set of inputs. Tau is a tape symbol. Delta is a transition. Q not the starting state of the Turing machine. B is a blank symbol of the tape. Tape is a final state of the Turing machine. Let us see that it's an infinite tape. Left hand side, right hand side is an infinite tape. So the B is indicates the blanks. The X1, X2, X3, these are all indicates Xi is the input symbols. Here we having a finite control, which is the CPU of the Turing machine, which controls the overall of the Turing machine. It have the read-write head. It can read one symbol at a time, write one symbol at a time, and move to either left hand side or right hand, depends on the control of the finite control. So input tape with the tape symbols. Input output tape symbols are initially X1 to Xn. So B is indicates the blank symbol. Say tape is a memory. Is a tape head will read or write. So like it's a CPU, which is overall control of the Turing machine. So transition of the Turing machine, let us see that. So Q is the one state, P is the next state, move, one move. The Turing machine does the following. The movement will be used like this. X is the input, Y is output, D is the direction. Let us see that delta Q is the present state, input is a X is equivalent to, go for P is the next state, this X is replaced by Y is output symbol, direction, D is the direction, which direction moves to, so Q to P is the right direction. Like the transition function is going on, Q is the current state, X is the current input symbol of the tape, state changes from Q to P after the move, X is replaced by Y, D is the direction, either left hand side or right hand side. Instantaneous displacement of the Turing machine. Instantaneous displacement of Turing machine is x1, x2, xi minus 1 is the q. Present q is the xi plus 1 up to xn means q is the current state. The tape head is positioned into xi. The position is xi. x1, x2, xi minus 1, xi plus 1, x1 is the current tape symbols. So delta q xi equal to p y r is same as x1, xi minus 1, q, xi, xi1. This indicates it goes to x1 dot xi minus 1. This x is replaced by y, the p is replaced by q is replaced by p, xi plus 1 is xn is the moment of the Turing machine. Similarly, q xi equal to p, y, l is the same as is the x1 dot xi minus 1, q is there, xi onto xn is replaced by, so the q is replaced by p, xi is replaced by next state is xi minus 1, the x is replaced by y, so xi minus xi plus 1 dot up to xn. So why to check the membership? The string is accepted by Turing machine. Initial condition, the input string is present in the Turing machine preceded and followed by infinite blank symbols. Final state, acceptance. If W is the Turing machine enters the final state, halt. If the Turing machine halts, not final state, then reset. Examples of 0 power n, 1 power n, n greater than equal to 1. So there are 3 input symbols. 0 power n means 000, 111. The blank symbols are blank, 000, 111 in the listed in the tape. These are the blanks, blank 1, blank 2, 000 listed here, and 111 followed by 111. These are followed by blank. So first, when going for the input read, the first 0 is read by the Turing machine replaced by x. The remaining 0 will be skipped to on right. We find out the first one replaced by y and turn back to left. First one is replaced by y and turn back to left until finding the x. Next repetition. So it will start from again 0, 0 will replace by x and go on right to 0 and y will be skipped and go on finding until the 1. First one. If 1 is found, that will be replaced by y and coming back to until getting the first x. First x is found means you go for right hand side and the 0 will be replaced by x and go on to right hand side until finding the 1. If 1 is found, then 1 is replaced by y. So move on to right hand side. If a blank is found, we can say that the input string is accepted. Similarly, the same problem, designing of the Turing machine, 0 power n and 1 power n, where n is greater than or equal to 1. Starting state is a Q naught. So mark the input symbol unread 0 and replace it with x, move to right. 0 and replace by x, direction is right. Go to Q1. Next, move to the right all the way. The first unread one is found. If you go for first unread is found, make it is y. So zeros right hand side. Y is right hand side. You go find our first unread one. If found unread one, make it y. Then find to left. So then move back to the left all the way. Last x mark is found. So if you found, so y is there means move left. So move until the left mark is found. If this left mark is x, then the x is replaced by x, move to right hand side. Then again it will start to second cycle. So all 0 1 be replaced by x. These all skip 1 replaced y. This will coming left. So this cycle is repeated twice. So finally, so all the zeros replaced by x, all the ones replaced by y. And finally, move to right hand side, blank we found. Once you move that portion, we can conclude the input symbol is accessed by Turing machine. So all this replaced by. So all the y's are replaced. Move on to right hand side. All the y's are replaced. Go on to right hand side. Then it's found a blank. The blank is replaced with blank. Right hand side is go for Q4. The Q4 is a accepted state or final state. This is a tabulation for all the states. There are 4 states are there. The input is 0 and 1, x and y, blank. So this is a table moment. That means Q naught 0. So Q1 will goes to Q1. 0 is replaced by x. The direction is right. Similarly, so current state, current input symbol, direction. Similarly, all the tables should be the table. This is a transition table for 0 power n, 1 power n for the Turing machine. Turing machine calculations. Turing machine can also be used to calculate values like algorithmic calculations. Example, addition, subtraction, multiplication, all the purposes used. The language of Turing machine. Recursive enumerable language is the Turing machine language. So there are hierarchy of languages called regular languages accepted by finite automata. DFA. Context language accepted by position automata. Context sensitive accepted by linear bounded automata. Recursive enumerable language accepted by Turing machine. These are hierarchical variants of the Turing machines. So multi-track, there are multiple tracks are there. In the Turing machine head will go for track 1, track 2, track 3. So this type of function will be done by the Turing machine, which is called as a multi-track Turing machine. Multi-track Turing machines, multiple tracks will be just one head will be there. Go on to read, which track you want to read. Similarly, multi-tape, after that it will read to finally multi-tape Turing machines. The Turing machine will multiple tapes, each tape with a separated head. So multi-tape, one head. So second tape will be the third tape. So multi-tape, each tape will have separate, which is called a multi-tape Turing machine. So it's a non-deterministic, non-deterministic, almost both are same. So similarly, Turing machines, recursive enumerable language. Turing machine can also use to both language recognizer as a calculator. The basic Turing machine is equal to all the above. Turing machine plus storage, multi-track Turing machine, multi-tape Turing machine, non-deterministic Turing machine. Turing machines are likely universal computing machines, unbounded storage. Thank you for all.